We're working with the Moonshot Museum and welcome Jimsy and Mike here today. So we are creating a multiple player game inside the VR, installing in the Moonshot Museum. We aim to spark the interest of the middle school students to figure out more possibilities about the space careers. So the project was revolved around a series of lunar missions for the explorers set in the 2050s in the near future of our target audience, so that once they grow up, they can know that in some point back then, they have explored a series of missions trying to build up habitats after collecting minerals, crucial resources to explore most possibilities beyond the universe. And the experience, imagine a group of students will come to the museum. They will first come to the little theater inside the Moonshot Museum, watching a film about 8 minutes, and then talking about the introduction about the museum itself, and about the history, and also the future mission. Then it comes to our game. And 2 players will be inside the VR headsets, and the rest of the audience will watch the screen, projecting whatever the players are seeing inside the headsets. They will talking to each other, and usually we also found that the parents will be taking pictures and also talking to their children. And after this game, they will explore the rest of the museum, get more hands-on experience, learning more fun facts, and also more serious scientific facts. And here is what you will see inside the game.
So at the beginning of the game, the lander departs from the Earth and lands on the moon. And after the rover come out of the lander, there will be UI showing the basic operation. And this UI shows which elements the player need to build these settlements. And then mining mission starts, and the first elements the player needs is oxygen. This is the installation in the museum. After the player collects enough oxygen, they can build the oxygen generator. And then they can upgrade their rover from level 1 to level 2. They will get more powerful wheels and a laser gun to make the digging experience more efficient. And they are digging more silicon and aluminum to build 2 more settlements for their base. At the end phase of the game, a dome will be built, and the player can plant vegetation inside the dome to make the moon environment more sustainable. Yeah, that's the whole process of the game, and I'm going to talk about our design process. So at the beginning of the semester, we receive the high-level objectives from our clients, and we are tasked to make a 2-player game, a VR game, and a game featuring Moon Rover as the main protagonist. And based on this high-level objective, we communicated with our clients a lot, and then we did a lot of research to come up with some more detailed high-level design decisions. So from the discussion from our client, we identified several keywords. The first one is Cube Rover. It is the central theme for our game. The second one is mineral, which is important resources on the moon. And in the real world, is also digging minerals is also the the main task for the Moon Rover. And the third keyword is robotic arm. It will add more possibility to the design for the gameplay and also add more interaction within the game environment. And we also want to have a more clear tone for the whole game. So we asked our clients how realistic the game will be. And we let them rate from 1 to 5. 1 represents the pure fantasy, 5 represents pure scientific. And we got a rating of 3. And that's very crucial for our later game design. And we are making a 2-player game, but are they going to control one rover, or are they going to control two rovers separately, is a main design choice we made in the early designing phase. And we finally decided to let the player control, two-player control same rover, one act as the rover driver, one act as the robotic arm operator. It will reduce the downtime caused by the different skill level between the two players and make the whole experience more continuously. And based on all those high-level design decisions, we come up with more detailed design decisions. Here's our game loop. So the player, they find and travel to minerals, they're digging and collecting minerals, and they can use the mineral they collected to upgrade the rover and also build their moon base. And at the end phase of the game, there is a transition to planting tasks. And to add the variety for the gameplay, we also design a rover upgrade system. So as you can see, the player can upgrade from the left one rover to the right one. So the difference between these two is, first, the wheel of the right one is like more powerful, so the speed is faster, the friction is stronger, and the controlling feeling is better than the first one. So the player can climb up previously inaccessible slopes beside the moon crater. And also the arm upgrade from the drill to the laser gun. So it totally changed the digging experience. And we also select three most representative elements from the matrix provided by our clients, and we link the properties of those elements to the function of the settlements the player are going to build. And in the end of the game, there is a planting task, and the player can plant inside the dome to make the moon more sustainable and also completing the whole experience. And now I will hand it over to Jimmy to talk about the tech side.
For the tech part, our biggest concern, one of our biggest concerns as a driving game is, of course, the driving experience. So our main goal is to simulate a kind of realistic driving experience on the moon. Therefore, we use the wheel collider for accurate wheel control in Unity. With this set of API, we can easily manipulate the torque of the car, the forward friction and sideway friction of the wheels, and even the suspension system of the car. So we can customize our own driving experience on the moon. So with this high customizability, we made two sets of vehicle presets for normal and upgraded rover by leveraging the realism and learning difficulty, since our target audience are only middle school students. And another important concern is the VR camera perspective. According to our playtest feedback, most players tend to feel motion sickness due to the previous fix to the car camera. So to resolve this issue, we asked Jesse and Dave for some technical insights, and we completely rebuilt our camera system. So currently, our camera will catch up the rover smoothly, and we greatly reduce its tilt and rotation. Furthermore, inspired by Ruth feedback, we add a lot of custom animation into different stages of this game, so as to improve the immersiveness of the game story experience. And of course, as most of you know, that networking has always been a challenge for us throughout this semester. We use the Photon Fusion API, and it requires networking scripts and components for every synced objects between the host and the client. However, since this is a rather new API release last year, we did encounter many unexpected technical issues, and many simple tasks such as bug testing could be very torturous in VR networking situation. Moreover, we need to redesign the UI in world space, since this is a common practice for VR games, and every piece of VR element needs to be networked, which could take a lot of time. But fortunately, we almost solved all the technical issue at the end of a semester and could hand out a working deliverable, which gave us an opportunity to learn and during this networking journey. Now we will come to the R part.
Thank you, Jimmy. So, since a big part of the game is collecting minerals, we design a crater which naturally will form the minerals. So start with a basic crater, we gradually refine it, shape the terrain to fit the design for multiple levels and purposes. So let's talk about the minerals. Each mineral has 3 stages. Each time it breaks, it produces collectible debris. These elements serve as essential resources for building settlements and supporting life on the moon. Our client provided a project matrix that combines scientific accuracy with suggestions that led us to engaging experience. Thank you. The rover is an unmanned flexible vehicle. Initially, we created side and perspective views. And then as we developed the in-game rover movement and camera perspectives, we shifted our focus to the back of the rover, as that's what players see the most. This led us to pay more attention to the wheel sizes and placement and proportions of the arm. Next, we have Kira to talk about UI UX.
Based on playtests, we iterate our UI UX 3 times to improve the whole game experience. So the first iteration, we changed the UI color. The original blue color was hard to see. It's against the gray rocks. So after testing different color, we chose green, which is made the text easier to read. This is how UI elements. And the second iteration is we changed the UI placement. Because at first, the UI floating in the air, so the players in VR had to look up or turn around to find them. So they often missing some important informations. So to address that, we decide to place in UI at a ground level. So it make them easier to see and read. So the third iteration is we improved the tutorial, because during the playtesting, we found that a lot of players, they don't know how to use the controller. So we add simple and clear the tutorial to help them quickly understand.
So I'll talk about the playtest furthermore. We have been through 10 plus rounds of playtests holding more than 130 guests. There are alumni and faculty of the ETC and middle school students, also groups of guests coming to the Moonshot Museum. And here are some pictures of the playtests. So the first playtest reflection we got is we need to balance the experience between the 2 players. As we see, the rover driver is taking more part in the game, so we add something to the arm operator for him to do. So the first thing is the UI identifying the minerals can only be seen by the arm operator, so the arm operator is in charge of communicating these information to the driver. And also, after the upgrade, the arm will have a very powerful laser shooter to shoot minerals from afar and break it much easier. And also, the other thing is the driving experience. Originally, based on the scientific fact on the moon, the gravity and friction is much less than that on the moon, on the Earth. So our original driving experience is not that good because it is very fast and slippery. And now we increase the friction on the moon and also reduce the rover's power. And it makes the rover much easier to control and can still drive reasonably fast. And this is our installation plan. We will hand our in-person walkthrough recorded video, including instructions for build and script, to our Moonshot Museum staffs. And also the design documentation will also be delivered.
And we also designed a physical ticket for them to print out and for kids to take home, and so that they will find that way before that their spark interest might just happen years ago. And throughout our installation playtesting, from the feedback of our clients, this makes them find more possibilities of younger generation become more engaged inside the museum. And we really appreciate that this project is already engaged in the resistance found from the NASA and opening in the holiday soon, and also carrying around in the next spring to more schools. And to sum up, we are creating a multiple player game in VR, installing in the Moonshot Museum. And now we are open for questions. Thank you.
what would you say is the most important aspect of this project that is unique to this project?
I think normally people see VR as like a single, relatively closed game experience, but what makes this special is that we are projecting whatever people say, the players see inside the VR with the audience, so all of them could be part of the experience from different perspective, and the communication and conversation, their interactions are really matters, because different people inside one family act different roles. The mothers usually taking pictures, talking to them, fathers usually acting as a commander, and the kids are having fun. This is really a unique experience for the Moonshot Museum as itself, designing a great experience of the location-based entertainment, and so I think this is a great combine.
So for in the first part, you have the drill, not the laser. Can you talk to me about how you made the drill impact texture dynamic?
This is actually a simple decal effect.
Decal, okay.
Yeah.
Hi, I'm Mike Hennessy. I'm the manager of learning programs at Moonshot Museum. I just thought we'd weigh in with a client perspective real quick too. First off, come on down to Moonshot if you haven't already. One of our challenges is showcasing a future that's always emerging. And so early on, we decided we didn't want a game about the robots that you see today, which could change designs in 6 months or a year, but still realistically reflected the robots of tomorrow, that the rising middle schoolers who come to our museum could be designing extrapolated from what they see today. And I think there was a lot of iteration, a lot of back and forth, and the team was just super responsive with that, and really appreciated the creativity there and the innovation. And also designing a game that opened things up for throughput, in a museum. It's fun and engaging, and just the right amount of time for the next group to come. So kudos and thank you.
Thank you.
Hi, everyone. My name is Dr. Jamise Brown. I'm the executive director of Moonshot Museum. One of the things that I appreciated about the group, excuse me, is that as all museums are very educational, but with us being focused on career readiness, we really had to find ways to inspire the youth to want to dive deeper, and also highlight careers that are external of the monolith for the aerospace industry. When we look outside of astronauts and engineers, how can we highlight people within mission control? How can we highlight those within IT to then dive deeper, as Mike had spoke about, through some other educational programs? And I thought that the VR experience that they created allowed us to instill that bit of inspiration in kids, to get them excited about what's going on in the aerospace industry, and then allow us to accompany that with some more educational information. And also, this is a surprise to them. They don't know about this yet, but the experience went so well, the testing went so well. I had the opportunity to present this along with some other accompanying VR experiences to a foundation, and it went so well that it got funded to help us with our NASA grant. So this will be in Western Pennsylvania, Eastern Ohio, Northern West Virginia, so much so that they gave us sizable donation to ensure that all kids have the ability to have VR experiences to not only ignite their passion for space, but to educate them as well in the industry. So kudos about inspiring the next generation and it being engulfed into our NASA grant.
Thank you again, Dr. Brown. Thank you, Mike, for the great support.
That is time. So thank you very much, team.
Thanks.
Okay. Good morning, everyone. This is Team Brada, and we're doing real-time virtual production this semester. This is our team, and we have John and Ruth as our instructors, and we're also lucky to have Chris and Derek as our creative consultant, and Zach and Todd as our SMEs. So before jumping to the journey of virtual production, I want to invite you guys to watch an overview video of our project.
Hello, welcome to the Barada Virtual Production Experience. My name is Alice, and I am a metahuman. Today, I'll guide you through the fascinating world of virtual production and share the journey behind our project. Barada Virtual Production is a 12-week exploration designed to evaluate cutting-edge virtual production technologies and establish a practical pipeline for the Entertainment Technology Center at Carnegie Mellon University. But first, let me explain what virtual production is. Virtual production bridges the gap between the physical and digital worlds in real time. It combines traditional filmmaking with modern technology, empowering creators to bring their visions to life more seamlessly. Unlike traditional filmmaking, which progresses step by step from pre-production to post-production, virtual production merges these stages. Directors, cinematographers, and producers can visualize a nearly finished product earlier in the process, enabling rapid iterations that save time and resources. In our project, we built two primary pipelines: a real-time in-camera VFX system and a motion capture workflow. Now, let's take a journey into the virtual world we've created. Allow me to introduce our Wonderland scene. Inspired by Alice in Wonderland, we crafted a whimsical, surreal environment that invites creativity and embraces the unexpected. Its dreamlike quality not only sparks imagination, but also harmonizes with the occasional technical challenges. For our in-camera VFX setup, we used a 270-degree projection wall powered by Unreal Engine's end-display configuration and a Vive tracker. This setup seamlessly merges the real and virtual worlds. The projection wall displays our scene, serving as both the background and lighting source. The end display system ensures the virtual and physical spaces are perfectly aligned. The Vive tracker syncs the virtual camera with its physical counterpart, creating a cohesive illusion of space. We also used physical lighting to match the virtual environment, enhancing the realism of our scene. Next, let's talk about me, Alice. To create me, we began by scanning a real actress, Jinyu, and generating a digital version of her. Using Marvelous Designer, our artist created a virtual dress that mirrors the physical one. It's rigged to allow me to move freely. My movements were brought to life through motion capture, powered by the RemoCap plugin. By capturing real human motion, I became more than just a digital character. I became a bridge between technology and storytelling. Thank you for joining me on this journey. Our goal was to establish a foundation for future ETC students to explore and innovate in virtual production. We invite you to step into our world. Try our interactive motion capture demo, explore our virtual environments, and see firsthand what's possible when technology meets creativity. The future of storytelling starts here.
I hope this video can bring you back some memories of the virtual productions that we did and some impression of that. So next, I want bring you back to the festival night and talk about our setup for the festival. So our goal for the festival is to design an interactive experience for the guest who doesn't have a prior knowledge about virtual production and understand what virtual production is and how the workflow works, while they can having fun and engaging through our experiences. So our setup there are three parts of our setups. The first will be the motion capture. We have the facial capture and the real-time camera-based motion capture so that the guests can understand how we bring the virtual character to life. Besides that, we also have a real-time in-camera VFX station where the guests can hold the tracker and understanding how we match the virtual world and the physical space. And then we also showcase our virtual assets and the physical asset and how we match these two set of assets together. Next, we're going to talk about in detail how we build these workflows and the assets. For the motion capture, we use LiveLink plugin for MetaHuman to capture the facial animation of our character. And for the body movement, we use RemoCap with an AI-based camera webcam motion capture software to capture the motion. In Unreal Engine, we were able to combine both the facial and body movements simultaneously in real time. And the reason why we use this pipeline is because motion capture is widely used in virtual production industry as a digital substitute of real actors, specifically useful in shooting wide shot, and it's also important in gaming and animation industry. In the process, we realized that the LiveLink facial capture has like limitations in accuracy when recording lip synchronization. So we tried the experimental feature in Unreal Engine 5.5, which generates lips animation directly from audio source. Although it is not real time, we combine it with the real time motion capture data, and it greatly increases the performance and accuracy of our final animation. We both tried the mocap suit and the camera-based motion capture, and we opt for the camera-based motion capture during festival because it is really easy to set up, and the guests can just walk in to experience the motion capture. However, we feel like the motion capture suit is better for a professional motion capture production as it has better accuracy and stability.
To begin with, let's watch a demo clip of the in-camera VFX we shot in the ATC cavern. We want to highlight the light emission effect provided by the projection background. As you can see, the reflection picks up and blends the image of physical props and virtual background together. And this is what a green screen technique is not able to achieve. Another important aspect of real-time in-camera VFX technique lies in real time. We created dynamic environmental elements, and thanks to Unreal Engine, we're able to program them in a level blueprint and have them trigger on keyboard or on Vive Tracker Collision real-time on set. And dynamic lighting is also what makes real-time virtual production very special. However, due to the limited graphic performance of our render station, we were not able to achieve real-time frame rate using Unreal Engine's global illumination, which is Lumen. Thus, we researched on static lighting and baking light maps. What you're looking at right now is a light complexity profiler of our scene before the optimization. Even though the rendering was realistic, the complexity maxes out in most of the areas, causing big lag that hinders the real-time rendering. After baking static light maps for static assets, you can see the profiler shows a decrease in overall complexity, and now we're able to leave the budget for a few ray traced dynamic light to render real-time. And here's the result. Now our scene is dynamic and efficient. We use other optimizations like setting LODs, level of details, and taking out meshes that with high poly counts, boosting the frame rate more than enough for real-time virtual production shooting. And we'll have Yue to introduce what we did on site.
So these are our shooting equipment and our storyboard. So we separate the storyboard process into two steps. First, we came up with the sample shots to showcase the essence of virtual production, and then we convert them to a detailed shooting guideline specifically for in-camera VFX. And this is our in-camera VFX on-site shooting workflow. So we used the camera for the background and made it more authentic by matching the lights between the real and virtual world. And we used real-time color grading within Unreal Engine for light matching, and finally shot the footage we needed. But due to the limitations of the camera's low resolution, brightness, and color gamut, our raw footage has some minor issues. For example, you can see there's underexposure and excessive noise in certain areas. So to fix this, we used post-production tools like Adobe Premiere and DaVinci Resolve to complete editing, color correction, noise reduction, and color grading. And also we created a comparative version that includes behind-the-scenes documentary footage in order to showcase the connection between our shooting process, methods, and the final footage. And next, we're going to talk about art. Thank you.
Here, let's look at our asset creation process. So just for the recap from Have, we made the wig based on metahuman hairstyle, and we did the face texture to match Alice's makeup. After Have, we finished the dress in detail, including the gathers and the laces to fully replicate the dress from the physical world. In order to make the dress to move along with the character, we also did the weight transfer from metahuman skeleton to the dress. So here's how it moves.
So for environment, we created a new gallery space outside the hallway, so it better aligns with the narrative context of Alice peering through the painting frame to see a magical world inside of it. And after Have, we continue to make more digital replicas, such as the tablecloth, the cake tower, so we can switch between the real and the virtual setting. So here's an overview of all the assets we created. And here are some renders of the scene. So here's Alice sitting and talking in the scene. And this is a side view of the entire hallway.
So besides all the exploration of the workflows and technologies, another important part of our project is to have a documentation of the whole process so that the future EDC students and the virtual production projects can use it. This is the structure of our documentation. We have different parts. We have an introduction section where we introduce the concept of virtual production and different workflows so that people can easily get started with. And we also documented technical setups, instructions, and documenting everything we tried this semester, whether we successfully embedded them into our pipeline or not. We hope that future students and projects can easily follow it and iterate it. We also have the documentation of our assets creation and the on-site shooting practice. So we hope the lessons we learn from it can help future students to create virtual production projects more creatively and efficiently. To sum up, we are a 14-week discovery project aiming to exploring the pipeline, virtual production pipeline here at ETC. We build in-camera VFX and motion capture workflows and have a documentation of it. Thank you for listening to our presentation, and we're open to questions.
So I've been very impressed by what your team has been able to do in terms of generating, especially motion capture and digital backgrounds for film projects. Are there parts of these technologies that you think could also be useful for games or VR or other kinds of interactive experience that are beyond film?
I think a lot of games nowadays are using motion capture for their cutscenes, so this is very well connected to what a game studio would be producing. For other aspects, I think it's helpful for our team to learn the optimization process and creating assets in the mindset of cost efficiency, and that's also connected to game production for artists. Yeah.
So in some brief conversations I had with you guys earlier, there are a lot of other aspects to this. Like, you guys didn't get to explore everything. So if there was a continuation of this, do you have like a list of other techniques to be explored that you guys didn't get to? Like what would be next?
I think the green screen and miniatures, because miniatures takes a long time for production, and we just are occupied with the pipelines that we have now, but definitely we want to explore more in that. And also the more experimenting on reflections of objects in a emission LED volume. For example, a car model or for a car shoot or something like that. Yeah.
In the footage you showed, what was the focal length of the lens you used, and did you experiment with different lenses?
We have mobile phones and a Canon 5D, and the focal length varies, but one good thing about the in-camera VFX system is that when you can expand the frustum, and then so when you zoom in or zoom out, the image is still perspectively correct.
And for the lens, the range we have is 15 millimeter to 70. The lens.
70.
Yeah, 70.
Did you have footage of zooming in and out with the lens?
We basically tried like different like shooting, how to say that, focal length, but we basically shoot based on our storyboard. So we finally like decide one focal length for shooting.
But in the technical like testing shots, we do have different footage of us testing focal length and shutter speed and that kind of things. Yeah.
Not so much a question, but I hope you guys all at this point realize and appreciate the benefit to your educational experience by not being given a $10 million professional grade system. That could also be beneficial, but I really appreciate how you guys worked around the constraints and came up with your own solutions where the technology was lacking.
Thank you.
Thank you so much.
Good morning, everyone. We're Team Sync Night. And up on the stage are our team members, and we have our instructors, Heather and Mo. And our music composer is William, and Brad is our SME from Epic Games. And before we start the presentation, I want to invite you to see a demo reel of our project. Welcome to Project Sync Night, where the worlds of music and gaming collide like never before. Built within the limitless universe of Fortnite, Sync Night transforms traditional concerts into an interactive multiplayer adventure. In a 12-week production time, we designed this platforming and boss fight experience that evolves with each chapter's unique musical theme. At the heart of this innovation is Unreal Editor for Fortnite, or UEFN.
a powerful creation platform that lets developers like us craft immersive experiences directly within Fortnite.
World, look at me. Welcome to my concert. I am at the cutting edge of the era, the pinnacle of sophistication, the flawless instrument made from all the sounds in the world, forming perfection. Perfection. I am perfect. I am perfect. I am at the cutting edge of the era, the pinnacle of sophistication.
I hope this provides a little bit insight our project, and we will be talking about our project goals, our project, and also our process toward our product, and our success and failure. In terms of project goal, we wanted to create a multiplayer music concert that built within Fortnite. And why we're building this? Because first of all, we are the first team that ever used UEFN to build a project. And we wanted to explore the Fortnite creative ecosystem, especially in its sound ecosystem and its gameplay integration. And we wanted to introduce this UEFN to ETC as the project can use it in the future. And I'll let Charlotte to talk about more of our product.
Thank you, Selena. So for our game, we created a smooth linear experience that includes many music syncing platforming chapters, which are supported with a diverse art style of environments. And these platforms all lead to a concert-themed boss fight in the end. We created a narrative in our game to support this experience. Our protagonist is this old piano that you see right here. And after hundreds of years has passed, it will transform itself into a cyber robot boss by adding different types of instruments onto itself. In our platforming chapters, we will lead the players as a group to go through our protagonist piano's life, from a childhood maze, a castle of drum parkour, a string instrument grand rail, to a hoverboard cyber city. On their way, players will collect music notes that adds points to their scoreboard. In the end, players will apply the gameplay elements that they learned in the previous chapters to the final concert, where they will defeat the boss and unmask what is hiding inside of the disco ball. For our environments, we will be needing a large amount of diverse art assets for different maps. Therefore, most of the assets that we used are suitable assets that we picked directly from the UEFN asset store. This way, we can build a large amount of environments in a very short period of time. And next, Yihua will introduce our process.
Thank you, Charlotte. So before we actually dive into the actual production, we did some research on the previous Fortnite concerts. We want to find out their traits, what makes them unique, and we want to find out what makes them fun. So we did some research on the previous Travis Scott concert, the Eminem one, the Metallica one, and this is the Metallica boss fight. So we managed to find out that all of these concerts have one thing in common, is that they have something that draws players' attention, or a spectacle. So we managed to create a boss fight arena that's filled with amazing visual effects and a boss fight to actually increase the player interactivity, so the players can have a experience, very interactive experience. So this is what we managed to create. This is the boss fight arena. Next up is the gym level. So what a gym level is basically a testing ground for us to test our UEFN functions and nail down prototype boss mechanics. And also, we worked with patchwork devices. Those are basically UEFN devices that allows us to sync the boss's movement, the platforming course's movement, and the mechanics with the beat of the music. And we also assembled the boss to give us a actual feeling of what the boss is actually going to be like, whether it is the scale or the feeling of combating with the boss. And also, group creativity is also a very key element in our design process, meaning that all of our members contribute to creating in the creation of mood charts, storyboards, drawings on the wall, etc., as you can see at the bottom. And for our boss fight production, first off, we took in some existing gym level mechanics that we built earlier, And then we separate those attacks into different boss phases, so the players can have different interactions every single step of the way. And also, we want to emphasize the musical element within our experience so that we sync the prop within the boss fight arena and also the boss's attacks itself with the beat of the music. And also, we emphasize the multiplayer element of the boss fight as well, meaning that players have to actually collaborate with each other to actually defeat the boss in an efficient way. Also, we use the boss fight to conclude our narrative, and also we had a cutscene at the end to conclude the narrative as well. And during our process, we do a lot of playtest and iterate. And next up, Aaron is going to talk about the level production.
Thanks, Yihua. Level production, here's our level layout from the top view. And in this project, our level production workflow is as follows. Initially, the level designer outlines the entire game flow in a text document, and then presents this to the team for discussion. Once approved, the level designer jumped into the engine to do the block mesh, also known as Graybox. In this step, core elements for the level, like gameplay elements, the rough layout, and the thematic direction for each part of the level were determined. And then, after internal playtesting to assess its functionality, the level designer collaborated with the artist and the composer to refine the overall experience. Here are some key methods adopted in our approach I think is worth mentioning. First is text level design. Before any tangible development begins, the level designer defines the entire experience through text. This documentation includes the goals and requirements for the level, potential elements and the mechanics to be incorporated, a step-by-step expected player experience, and any pertinent questions and concerns that need to be addressed. The benefits of this method is that it allows us to define the experience with the lowest cost and the highest speed. Another key method that's enabled by UEFN is module level design. As you can see, each floor tile, stair, window, and so on are individual pieces. And UEFN provides really a ton of choices with different themes. It largely enhances the flexibility and scalability of level design. And the level designer can define the levels even further by assembling the pieces to build a relatively polished environment. However, on the other side, I found that a level designer needs to be extra careful about it, because it's really easy to get lost in details, spending too much time finding the perfect pieces rather than really focusing on the design part. Then next part will be introduced by Annie.
Thanks, Aaron. Let's take a close look at several main technical challenges we encountered and reflect on the lessons learned from a hands-on technical perspective, focusing on the iterative nature of development in UEFN and the critical balance between creative vision and technical constraints. One major challenge was long session load times during iterative testing. Unlike traditional engines, UEFN uploads levels to Fortnite servers and runs them in the game, offering a realistic experience but increasing testing time as projects grow. At one point, load time reached up to 20 minutes. Fortunately, with the latest version of UEFN, we observed a reduction in loading times, which highlighted the importance of staying updated with the most recent tools and patches. To improve rapid iteration, we leverage UEFN's ability to reflect changes like creating, deleting, or moving assets without relaunching sessions, reducing the need for full reloads. For changes requiring a relaunch, such as script updates, we batch multiple updates into a single session. While this deviates from the control variable approach of testing one change at a time, it allows us to test complementary updates together, striking a balance between efficiency and testing integrity. Another challenge we faced contributing to the load time issue was the memory capacity limit. With only one map allowed and a set memory cap, we need to ensure the stable performance during runtime. By the end of the semester, we worked to keep memory usage at about 80% of the limit. To address this, we implemented strategies like asset management that compromised on asset quality by reducing mesh details and simplifying textures, and memory monitoring that used UEFN's tools to identify and address memory-heavy assets. Another recommended strategy, but we didn't use, was word partition that streamed portions of the map based on player position. Next, Arthur will talk more about UEFN.
Thank you, Annie. So while looking back on the challenges and solutions with UEFN throughout the semester, we realized it's important to share you some context and an overview of this platform with you in terms of what's available, what could be better, and what are the challenges that are here to stay. Starting off from, honestly, the constraint, which is also within the nature of UEFN, is the fashion of it updates in a monthly basis. It brings good news because the advantage also comes from that. It brings you a lot of content that comes with the Fortnite update, but also some challenges that are fixing or what they brought up throughout every update. For example, like one of our compiling time issues kind of fluctuates in between compile time of 10 minutes to 20 minutes in between the semester. However, there are a lot of assets that can get you up to speed and really catch up to the process while you're setting up the game. For example, the locomotion that was already built up from Unreal Engine, and also level design tools that could help our designers to build up levels extremely fast. So throughout all these things that you could use from UEFN, what are the things really that will support you through the journey of building an experience in Unreal Engine, UEFN? One of the first things that I want to bring up is don't marry to your ideas or technical solutions. Well, it's really exciting sometimes to build a feature that fits within the constraint of what you're building. Plus, while they didn't have an animation blueprint, we tried to build a whole state machine for the boss that we're making. That was exciting when it first seeing the boss move around, seeing the boss transition from states to states. However, we sometimes get so excited to ignore the question of how expandable is that process? How expandable is to make the animation for the boss to fit the VFX with it, and that ends up kind of biting us in the end when updates sometimes break some of the features interconnections, and building the animation for these tool sets, building a whole game around this feature sometimes won't be stable enough to sustain you through the whole process, especially when it's updating every month. One other things that we learn is scoping down for the goal. We're scoping down when we're learning a new tool, heading into something, even though on the surface it looks like a lot of things are already set up, we need to keep the scope down so that we can save time for exploration, and then it comes to implementation, playtesting, iteration for the experience that we're developing. In the end, what's really heavily related to this live service cooperation, live service operation on the platform is knowing what's coming, knowing what they're updating on a monthly fashion, knowing what is coming in next quarter, which they have shared the Jira board with us to show that something is coming on our way, something is being changed in the future. So to summarize that, we are releasing a documentation, a postmortem documentation to help future ETC students to potentially use this tool. And on top of that, we're releasing our project on UEFN platform to show everyone what we have made throughout the semester.
Can you go back and state the original goal of the project, just to help me out here? Got it. And so over the course of the semester, so this was the goal, create a multiplayer music concert experience within Fortnite. What do you really see as like your most key learnings in doing this experience?
I would say iterations. Our key learnings throughout the semester of building this experience is prototyping things and realizing sometimes either they work, either they don't work. We gotta iterate through some of this process, and having playtesters ready for our experience so that we can decide what features to keep and what features that we want to extend. I think this is a process that we have learned a lot throughout the semester.
I worked on 2 AAA projects that built on top of Unreal's tech. And the monthly drop that you talked about was a disliked part of that process on our end as much as it seems to be a disliked part of your experience. That's how Unreal works, I guess. I guess they still do monthly drops. So if you were, now that you know that, how would you have changed your pipeline or dev process to adjust to that?
That's a great, really great question, because that's something we really want to answer and like highlight. Yeah.
They're dictating the rhythm of your build.
Exactly. And having sometimes the ETC semester schedule, sometimes development process don't really line up with what they want to do, especially when it was comical that right before the festival they dropped something, it was forced updated, and some of the things just broke.
Hence my question.
Yes, exactly. So to deal with that issue, I think one of the things that really comes from scoping the project, really comes from how you really design the project to begin with. Is the project in a size that you could fix or you could iterate through in a month? I think that's really a question on us to really answer when we're setting up a project with UEFN or something that updates every month. Can we really have a team that supports one side under development, like in development, and the other side trying to maintain what we already built? I think that's really a part of the things that really helps building this process of building a workflow within that platform, within the constraints. What other things I believe would be really helpful is knowing what's coming, having clairvoyance on when is it getting updated, when is it going to have something new, and set up really the important iteration process. For example, like the playtest, setting up the playtest right before the update. So even if it breaks, we have almost a whole month to really fix it after the update. I think. Does that answer your question? Thank you.
So as the ETC considers using this tool in the future for projects or courses or whatever, what kinds of projects do you think this tool is really good for? Aside from the obvious one, which is like a shooting Fortnite game. Does that make sense, right? What kinds of pitches and what kinds of projects should we do using this platform?
I'll take that question.
So I think first, if you want to do, for an individual project, if you really want to do level design, I think it's pretty good, especially like if you do like something like a third person or first person adventure, that the first person mode will be introduced really soon. I think it's pretty good because it provides really a ton of assets and great tools for creating levels. And for what kind of larger games, like say a team project with idea for this project, I think one way is to look at the Epic, the platform, what kind of experience other players are building on that. Like they made a lot of like tycoon games or like horror experiences or escape room, and like some horror experience or escape room, like sort of like a walking simulator in a sense. So it's largely defined by its gameplay devices and what Epic wants you to do. But if you really want to do some experimentation, to do something like, I'm afraid Epic didn't expect you to do, that might cause some problems. So according to, they provide you like first, like third person or first person adventure that mostly shooters, yeah, and they have pretty vehicle system, but well, only if you do not change its system, because it's not allowed. If you only want to utilize a vehicle, you have a lot of choices. So basically, pretty much what Epic wants you to do. It's very clear that the tools they offer to you.
Can I add something? Yeah, just add something short on top of that. It's honestly, they are opening up features as we're developing through the project. In the beginning of the semester, we realized like you can't control how the guns shoot, and now we have some modification over that. And I believe overall for stability or for playing to the strength of the engine itself, it is really a good tool for learning, for example, a pace of a game. If you're building an RPG game and you have all the components that you need, not building really a lot of new not really building a lot of new gameplay mechanics, but really using the tools itself. I believe like just overall using the locomotion of it and having like building levels to iterate through, building levels to have our designers learn about how much does it take, for example, for a player to traverse through the level. That is something it will really help in the project or in a learning experience overall.
Hi, we're Team Beyond Touch. So as we are wrapping up this 2-semester-long project, I think it's a good time to look back to when we started, back to when we were still Beyond Touch. So to see how we defined ourselves, to see why we started. I can still remember the afternoon when we came up with this name. It's a whole different story, but the point is with the belief that gaming experience on portable devices can spread beyond the little touch screen, we named ourselves Beyond Touch and settled our paths. So how we actually approach that? By incorporating physical data into social game experience, we focus more on the players, the humans themselves, and the interaction between players. So what physical data could be fun to enhance the gameplay? What kind of social experience do we aim to create? Inspired by the lie detectors in some movies, last semester we utilized the player's heart rate and created a bluffing game demo. The players enjoy it, and they ask again and again to play another round. So this semester, we polished the game inside out, and thus we have the first ever social game on Apple Watch published to the App Store. And what else could be fun? Here is the scene in Harry Potter. They're using their magic power to play a chessboard game. Well, as a normal human, we see our health and fitness data as our magic power. And we use that to play a multiplayer territory control board game. Paralleling with the heart rate bluffing game, we designed and developed this first ever async fitness board game to let players compete with each other by their daily fitness efforts. Both games will be discussed with more details later. To wrap up our work, we created 2 unique social experiences. By leveraging heart rate and fitness records, we make our players talk a lot and move a lot. And as a team, we are paralleling 2 big chunks of work. On the left side is the productization part, and on the right side is more R&D stuff. And all under our super cool Alternativerse theming. Besides these, we also had a dozen other prototypes experimenting with a variety of different gaming possibilities. Now, I will hand mic to our designers and developers to talk about our games.
So a quick recap of our first game, Auto Agent, which a lot of you have already playtested and known it. So we've combined heart rate and bluffing game into a social game experience to encourage people to talk more to each other. And as you remember, we've launched it after half presentation. So today, let me share some post-launch data to you. So we already have over 100 downloads and over 400 sessions played in the last 2 months. And we also have over 2,000 people clicking into our game on the App Store, all before we've done any marketings. And our next step is to officially promote and launch it. So in our mind, productizing an app is very different from simply publishing it onto the App Store. And that's one of the key lessons we've learned, not just by launching our game, but by putting in significant iterations and work to truly productize it. And that means releasing the game onto the App Store is not the end of the story. After launching, we still keep playtesting it and make iterations, and receive a lot of feedback. For example, some players found the tutorials either too fast or too long. Half of the players didn't realize that the live voting have multiple levels. And almost most players didn't understand how their scores or rankings were calculated. These examples remind us that the game isn't perfect yet, so we are continuing to iterate and refine the user experience. So for example, we designed the ending moment when players reveal their identities together to help them make sense of their scores. We later found that this moment was highly enjoyable for players, as they were eager to discover each other's identities and trying to figure out if they correctly guessed others' identities or managed to deceive others. And now, let's watch the latest commercial we're about to release to the market for our first game.
So, what can a watch do? Tell time, check your messages, answer a phone call, record your workout? Did you know it can do something else? It can make you laugh with your friends, help you get to know strangers, and spark conversations you never expected to have. With Beyond Touch, your watch can do all of that when you play Otter Agent on your watch. Be prepared. Your secret agent training begins now. First, get a mission code and synchronize your secret watches. As an Otter agent, your mission is to hide your identity. Tell your story under pressure while your heart rate is being monitored and revealed. Interrogate each other and watch as someone's heart rate rises. Finally, uncover who is the best agent in the team. The game is now live on the App Store. Invite your friends to download Otter Agent and play together. Interrogate each other and watch as someone's.
Thank you for watching. Do you like it? I do. Okay, before we move on to our next game, let's talk about some key observations we have in Otter Agent Truth or Lie. First, making a social game with physical data is possible, fun, and novel. When people first hear about our game, a social game about telling truth or lie and hiding identities, their reactions be like, okay, cool. However, when they learned that they can see each other's heart rate in this game, they are so much more interested and excited. Next, onboarding on phone is smooth, clear, and straightforward. And finally, our players have a strong enthusiasm for playing our game on other wearable devices they have. Therefore, based on these observations, we have made the following design decisions in our second game, Otter Agent Fitness Training. First, Truth or Lie makes people talk a lot to each other face to face. We want to explore an async game with physical data, but still maintain the same social level in our second game. Next, we want to explore other physical data, and we picked calorie for fitness training. Finally, what if we allow every smartwatch that can collect users' physical data to play our game. Now, I will pass to Shihong to talk about our game design.
Thank you, Matthew. Okay, so for our second game, we want to make an asynchronous board game that takes players' fitness data into gameplay, and we want the game to encourage players to move more. Here's a high-level gameplay loop. Players exercise to reach a daily goal, earn in-game resources, and spend them to conquer territories in the game. Most importantly, we want players to feel motivated by the game so they would keep up their exercise habit. So how does it actually work? In Apple's fitness app, users can set up a personal goal of daily burn calories and see a visualized ring filled up as they move during the day. We use this fitness data and translate the rings into in-game resources called energy points. And if you complete one ring, you get 4 energy points, which can be spent on moving your piece on the board and capturing tiles from your opponents. This is where the territory control framework of the game really shines, because the instant visual cues can provide direct positive feedback, and the uncaptured tiles can motivate players to reach a daily goal so they can expand. We conducted week-long playtests, and we found the idea pretty promising. By sharing data with the team, players feel more inclined to use their wearables so they can keep accurate track of their daily burn calories. And also, we found the players to be very engaged in a board game every day during our second playtest with a high-fidelity prototype. We also got some valuable insights from the playtest. First, the exercise behavior between players are widely different. Some prefer moderate weekday workout sessions, while some prefer intense weekend training sessions. So because of this, we let the players choose freely when to start and end the session, and we also try to avoid designing time-limited mechanics in our gameplay. And second, because the energy point rewards are calculated in relation to personalized goals, it may be unfair for some ambitious players who set their goals too high. So to compensate for this, we give an extra energy point for the player with the highest burn calories each day, and we tell them they are the best with an in-game notification. Yay. And finally, although our core game mechanics push the individuals to exercise more, we want to see more social interactions in the game other than just sharing a same board. We want to see the players encourage their teammates to exercise more, and we also want the players to do some shenanigans to the opponents and spice up the competition. And this is where gadgets come in, and I'll hand it to Ivy.
Yeah, thank you, Shihong. So gadgets are the spells that offers player unique skill shots that could change the current game states. And by closing their rings, right now players can not only get energy points, which are the moves, but also gadgets. Or they can choose to capture gadgets, tiles that's randomly spawn on the map using their existing moves. And for the team that is behind, it becomes a viable strategy to catch those tiles comparing to just overtaking opponents' tiles. And the key reason we add gadgets is to curate interaction that goes beyond one single player. So allowing you to apply skills to teammates. So for example, peer pressure. And when using peer pressure, it will auto-select the laziest otter in your team and grant all the teammates extra rewards when this laziest otter can close the ring. And during the entire gadget events, first, when someone uses peer pressure, both the user and the recipients will get to know who you picked and who picked you. And after the gadget mission is accomplished, in which the laziest otter exercises to complete their next ring, all the teammates, there will be a teammates offering not only grants your rewards, but also recaps like who is the one making efforts to your rewards. And together, the entire information flow creates a moment to synchronize the cause and effect relationship behind each gadget usage. And through our playtest, we found it makes the user more engaged and keeps them more informed by clarifying the story behind the scene. And overall, with 9 different gadgets, 3 rarity levels, and gadgets connects players together and make the game more unpredictable and enables unexpected turnarounds. And for the eventually outcome, we implement not only gadgets, but also the holistic gameplay flow within the UI design, always matching with the corresponding team color. And lastly, the final leaderboard, team progress, and the in-game quick encourage notification to your teammates. And together, all the modules make the game feel social, motivated, and dynamics. And I will hand to Tony for the takeaways we summarize as Team Beyond Beyond Touch.
Thank you, Ivy. We would like to wrap up our presentation with some takeaways. As you know, one of the semester's key themes is productization. To create the best possible product, we pushed ourselves to improve every aspect that could lead to better results. Our game is now available on the App Store, ready for download and play without any additional guidance, thanks to the inclusion of a tutorial. We've woven our other-themed story into the experience and carefully considered how players will engage with our game. At the same time, we pushed the product even further by exploring new dimensions. We expanded our scope to support a wider range of wearables, addressing challenges in gameplay, visuals, and social accessibility. We also experimented with more physical data, going beyond the considerations we once had when we were beyond touch. And most importantly, after 2 semesters of working closely together, we've not only become a strong team, but also great friends, right? And we've come to deeply understand that ideation is never a linear process. It thrives on a constant sharing, inspiring one another, and evolving ideas in parallel with creativity and productivity. This synergy has elevated our work to new heights, enabling us to showcase our game at events like Serious Play and preparing us for some challenges like Swift Student Challenge. And looking ahead, we aim to evolve even further, introducing more other-themed games as part of our independent studies or a potential Beyond Touch studio. And in summary, this wraps up our presentation of Team Beyond Touch. And thank you all for listening, and we're open for questions and answers.
Could you talk a little bit more about adding the gadgets and whether your claim that it makes it more unpredictable and more social, is that just a claim, or did you gather evidence for that?
I can answer that. So during our playtest, for example, we designed a peer pressure gadget. It will automatically pick the one who did the least workout in that date, and if that guy finish his goal that day, all the team will get rewarded. So during our observation, the teammates really put a tons of peer pressure onto that guy, and we like that dynamics in the game. With our team and some other EDC students. Yeah.
And also for the turnarounds, and also peer pressure, we found something interesting. It's like a corner case, but when multiple players use this peer pressure, and they will actually pick the same person. And when this person just complete the ring, he just got a bunch of gadgets and moves, and he can just boo.
So you began the presentation talking about last semester's game, and you ended your presentation talking about the possibility of you getting together after you graduate and forming a company. What do you think, from your perspective, was the biggest learning thing you accomplished this semester?
For me, I would say
for the team.
Yeah. we can go one by one.
Well,
yeah.
Answer it any way you want. I'm interested in what you as a group feel you accomplished.
Yeah, I think the biggest lesson we've learned is paralleling the productization stage and R&D stage. And the ideation process is not a linear process. The ideas can come up like in every possible time, and we embrace the chance to create something new, create something innovative, and as well as maintaining our productization workflow. Yeah.
So how should the faculty evaluate you?
Well, I can answer that question. Yeah. To this team, like your evaluation is not as important as how we evaluate ourselves, because like this project bring us together as a team, and then we enjoyed the working flow, like working with each other. The team atmosphere, the vibes are so great that we want to enhance this experience in our future. And then no matter how people evaluate us, we still want to try our best to make this happen. So,
yeah. I guess I know what Messi is trying to talk. So I think the best way to evaluate our work is to see how players react to our games, how they do they like the game or not? Do they enjoy it? Do they download it and play again and again with their friends and families? Yeah, and that's how we evaluate ourselves.
It's time.
Thank you.
Thank you.